Hey, hello everyone. Today I'm super excited to have this distinguished panel of industry experts and leaders, Azeem, Bhavya, and Xu. And today we'll talk about their views on building machine learning platforms on Ray. Um, so at the end, during the actual conference, we'll have Q&A discussions on Slack. So before diving into the fun part, we'll do a round of introductions. So I'll be your moderator for today. My name is Zhe, and I lead the Ray open source engineering team at Anyscale. And I'll let our panelists to introduce themselves. Let's just go with Azeem, Bhavya, and Xu, alphabetical order. Azeem.
Sounds good. Thanks, Jia. Thanks for having all of us here today. I'm looking forward to the panel, looking forward to learning from everyone and seeing how others are using Ray and what Ray is doing for everyone, as well as sharing what we're doing with Ray. I lead the data platform at Shopify, the entire stack from pre-processing to post-processing, and ML is part of that. And previously, before this, I was at LinkedIn. Obviously, I worked closely with Yuja. So that's my experience prior to this.
Great.
Nice. Hey, thanks for the introductions, and really excited to be here, and thanks for all the great work you guys have done on Ray. So my name is Bhavya, and I work for the core ML team at Robinhood, and my team is responsible for building a centralized ML platform for a data scientist so that they can train ML models at scale on top of our infrastructure. And before this, I spent time at Uber, where I worked closely with Shu. So yeah, thank you.
Yep. So thanks, Jer. My name is Xu. I lead a couple of software development teams at Uber's Michelangelo machine learning platform, specifically on model training and serving infrastructures for both classical ML and deep learning. My team is actually a major contributor to Uber's open source deep learning software, such as Harvard, Petastorm, and Neuropod. So everyone, please check it out. So before Michelangelo, I mostly work on distributed systems and infrastructure engineering. My interests are machine learning, deep learning, ML ops, and big data. So hope to meet new friends here and learn more about the production experience of Ray at other companies.
Great. Yeah, so a little bit about this panel itself. So this panel is to talk about this trend in the industries to use Ray to build machine learning platforms, or at least I hope this is a strong trend. So to start, I think the audience, including myself, we're very interested in learning how machine learning is used in your organization. For example, what ML use cases do you have, and what kind of machine learning do you do? So this time, maybe we can start with Zhi.
Okay, sure. So Uber is a very complex business. So we have rides business, we have delivery business, we have freight business. Machine learning is used across almost all the business functions. Specific to use cases, we have the typical kind of recommendation search, fraud detection, that kind of use case. But we also have a lot of Uber specific problems. Mostly go to geospatial problems. These are where this is a new class of machine learning problem that is very prevalent at Uber, but not necessarily so much so in the whole industry.
I see.
I can add a few things in terms of what we're doing at Shopify. So we're in the business of making commerce better for everyone, which essentially means we're focused on delivering value to our merchants. Part of that is creating an unfair advantage for our merchants who are running their businesses, entrepreneurs who are running their businesses on the Shopify platform. And the way we create that unfair advantage is through the data that we have for all the merchants. And we leverage machine learning in that context. So obviously some of the things that Xu, you mentioned with respect to recommendation, product classification is one of our largest use cases, fraud detection, and those sort of things. But I think a unique thing that we're looking to do at Shopify, we're not so far into it yet, but something that will come up is our merchants trust us with their data. And this data is merchants' data. So we are looking to build machine learning models that can leverage the data to create that unfair advantage for them, but in a manner that respects the trust that they have put into Shopify with their data. Translates to a lot of different things like differential privacy and all these other things that we care about a lot, that we are just starting on that journey. So that's kind of the context.
Great, very exciting. Anything to add? Yeah.
Yes. So yeah, at Robinhood, since we are in the fintech space, the privacy and security are top priority for us because customers are trusting us with their finances, which is why the most initial use cases we have for ML, they center around risk and fraud. And in types of machine learning, it's classical machine learning, deep learning, reinforcement learning, all of it. We are also starting to explore more use cases around customer support and referrals. But yeah, that has to come in the future.
I see. That's very interesting. So I actually, from the more technical end, Xu and Azeem, do you also mind touching on the kind of machine learning you currently, kind of the landscape? What kind of machine learning you're doing? Like, what's a rough scale from, for example, the size of data, the compute resources? Yeah, whatever you're comfortable sharing.
Yeah, so we have both classical machine learning problems. A majority of them use XGBoost, and also a significant portion of deep learning problems. And we have some reinforcement learning use cases as well. This is just lent to because of the complexity of Uber's set of problems. We have a dozen of teams of machine learning engineers across the whole companies, which the machine learning platform supports. They produce like more than hundreds of models, and those are retrained daily or weekly.
Yeah, so
sounds great. Yeah.
Shopify, I think I'll share a couple of things. So like Xu said, it's XGBoost, classical machine learning that's heavily used. Deep learning, I don't think we have as many models in production yet, but this is where we're going. There's a lot of work being done there. In fact, one of our largest models in production now, where we classify products based on text that folks have entered, 150 million parameters. It's a BERT model, BERT plus mobile net v2 for images, I believe. And we do inference on 400 million records, 10 billion images, that sort of thing. So it's a fairly large scale from that perspective. But I think the larger concern that I have as we're building the ML platform is how fast we can scale, because our data growth is about 5x every year. And compute is along a similar type of trajectory, which essentially means that we are running into problems much faster than, like, we build something today may or may not work in a quarter, just because of how fast we're scaling or how fast we're growing. So that is the bigger concern that I have, not necessarily the pure scale we're running at, but how fast we're growing.
Great, Azeem. I think that naturally leads to my next question. So I'd like to discuss with you the kind of quote-unquote Ray journey in your organization. Why Ray? For example, how were you supporting these important ML use cases, and what limitations do you see? What's the main motivations you start to evaluate or use Ray? So Azeem, do you want to continue your train of thought? It's great. Yeah.
So the history of ML platform and Shopify is surprisingly, like, we've gone through it. I mean, it's probably not a surprise that we've gone through a few iterations. We started off with the pure Spark-based setup, where we were running our machine learning models on Spark, and we were running into several issues there where we were not able to scale. Like, we were running the clusters, we were not able to scale, and there are a bunch of other things that we were running into. So the model that we were running with for the past year or so has been a combination of Spark as well as Google's AI platform, where we were able to deploy some of the large models using Dataflow and TensorFlow to Google AI platform, and we could get the scaling that we needed through that. But one of the things that we've run into in both of these situations is how fast we can bring in support for new libraries. and particularly giving the data scientists the flexibility to pick some of the latest advances that are happening. I mean, given the space we're in, right, there is just so many new things that are happening, and we would love to be able to use some of the things that Uber is open sourced, and we couldn't leverage them just yet. So this is when we started looking at we should build an open source stack for an ML platform that we can develop and contribute to as we need it, so we can move really fast at the pace that we need. Like, coming back to the positioning of how do we build an ML platform that really grows with the growth that we're experiencing. That's what led us to Ray. And Zhe, I think you did a presentation at Shopify on Ray, and that's when we talked about it. We went on this journey. We did look at Kubeflow in the beginning. We found it to be probably because we didn't know it as well, and we're not as connected to the community. We found it to be fairly hard to start with, and Ray was very easy for us to start with. And data scientists and generally excited about being able to do everything in Python end to end, from data prep to serving. So all of those things led us to the conclusion that, hey, let's build our next version of the ML platform on Ray.
Great, that's a great story and great journey. Bhavya, anything you want to add?
Oh yeah. So a lot of similar reasons that Azeem has, mainly because data scientists love to work in Python. And the thing I like about Ray is it has drop-in replacements for a lot of Python libraries, and it just distributes naturally. I think the other big win for us personally with Ray is that how easily we can integrate it into our internal Kubernetes cluster. And that is a major security win for us because, like I said, at Robinhood, security is like one of our biggest concerns. So this enables us to have all the security bells and whistles and connect to all the internal services at Robinhood to like pull data, scale data. So it makes the life of a data scientist much easier. And on top of it, it has first-class support for deep learning. And that is one thing we really looking forward to explore over the next few months. So as we keep on integrating Ray more and more deeply, it would naturally also enable us to have deep learning support on our platform.
Yeah, I just want to add, Bhavya, that's a great call out on the infrastructure. Like that was also one of the reasons that we are a Kubernetes shop end to end at Shopify, and we were actually excited when we learned that we could run Ray on our supported production platform without having to worry about spinning up our own infra. So yeah.
And to confirm, Bhavya, Azeem, both of your internal kind of resource management infra is based on Kubernetes. Okay, great. Yeah, Xu, anything you want to add? I know Uber is quite different in terms of infrastructure from Shopify, Robinhood.
Yeah, that is correct. So Uber's machine learning platform has a very long history. We are actually one of the pioneer when it comes to like having a end-to-end solution for machine learning. In the beginning, Michelangelo, the machine learning platform, was built on Spark. It is to solve this classical machine learning problem. As time progresses, we have more and more demand to use deep learning. And Spark wasn't well designed for deep learning use cases, and that led to us develop our own internal infrastructure and compute system to run the deep learning models. So for a period of time, we have Spark and this internal system that running in parallel to satisfy deep learning use cases. We have learned about Ray, I think, from last year, and we think it is one of the great way to abstract out the compute for both big data processing for both classical machine learning usage as well as deep learning. So they help us not only consolidate but enable a lot of newer use cases that facilitate the deep learning usage. So we are in the process of moving everything from I think like everything in the training side from Spark into Ray, as well as running our deep learning infrastructure on top of Ray.
Great. Yeah, Azeem, were you going to say something? I think that's really fascinating. I think to summarize what I heard, definitely big deep learning is a big factor. Especially in recent years with text, with multimedia, deep learning can be better utilized in your business use cases, and kind of supporting distributed deep learning with advanced features is definitely one benefit you see in Ray. So there's deep learning. I think I also heard the flexibility to use a variety and fast evolving machine learning libraries overall, the ease to add new libraries in the platform. That's the second thing I heard. And also, I think I heard the benefit of a more unified infrastructure across the different kind of things you need to do on an ML platform, and Ray can hopefully provide that more end-to-end abstraction. I think I also heard one very interesting point, especially from Azeem, about the technology being future-proof. It can grow with the growth of your need for ML and your business. Great. So anything you want to add to this, my kind of summary of the fundamental benefits, why you started with Ray?
Yeah, I also want to add that it has been great collaborating with the Ray with Anyscale and Ray team. We are the owner. We're the main contributor of the Uber's open source deep learning framework called Harvard. It is a framework for doing distributed training. It's been used in like supercomputing is from supercomputing to like over small clusters. And actually, like a few days ago, we have this new NVIDIA national lab supercomputer that's like latest using A100. So they're recommending Harvard for that. We have been actually the Harvard team and the Ray team has been collaborating very early on running Harvard on top of Ray. Right. So from there, we understand like the a lot of benefits as well as the very great collaboration with the team, and that's a huge factor for us, like Uber, to pick a technology to lean into.
Yeah, Gert, I think the open source nature and the synergy among other open source projects, that's actually, that's a very strong point. Yeah, we should definitely leverage that. Additional question for Bhavya actually is interesting because you worked in Uber for the ML platform and now at Robinhood. What's your observation on the quote unquote trend in the industry to have an ML platform? For example, a few years ago, I believe that ML engineers were mostly training models on their kind of own ad hoc stack.
Yeah. So like Xu mentioned, when I joined Uber's Michelangelo, we were building everything on top of Spark. And we were providing more of an end-to-end solution to a data scientist, which was like completely closed inside the ecosystem. With Ray, I think, and with all the technologies that evolved over the last 4 years in the ML platform space, now that we have to build it at scratch from Robinhood, we are trying to leverage Ray so that it can be more of a mix of self-serve and also some independence to the data scientist. So like I said, the good thing about Ray is that it's Python first, so our data scientists can code and scale their code both at the same time with like minimal efforts. So with the integration of Ray, I think we are trying to give more autonomy back to the data scientist while not necessarily making their code harder. So the things that we can achieve now with the help of like frameworks like Ray and Docker is that data scientists can adopt their current scikit or XGBoost or whatever flows into a distributed setting with minimal effort. So I think that's been a huge win for us, or like for the whole ecosystem in general.
Great. Right. So that's a great summary. And seems each of your organizations have already spent some time, right, either using or evaluating Ray. So I'm very interested in learning what's your experience so far. For example, what kind of positive impacts have you already achieved with the Ray-based solution? And on the flip side, right, so what caveats have you noticed? So those are also very important signals. Bhavya, do you mind starting with this part?
Sure. So one of my favorite features about Ray is the feature of Ray Client. So that enables us to decouple our notebook server and our training infra from each other. And it makes it really easy for our data scientists to collaborate on different notebooks on the server and then use Ray Client to actually start their training jobs. So that has enabled them to train large models without any change to their workflow. Basically, it's still the same notebook server, and you just use the Ray Client. So yeah, that's been one of my favorite features. And the other favorite feature I have is the autoscaler. So we can have different teams have their own clusters without interfering with each other and have their own security settings. And that's a huge win again because it improves the user experience drastically. So yeah, I mean, which is why the initial evaluation of Ray has been very encouraging. In terms of caveats, and I would also like to point out the great help we've been getting from the Anyscale team in going through that. And so we have been working towards enabling more end-to-end ML pipelines using Ray. And there is still some work to be done in bringing libraries like Dask and integrating them with the traditional model training flows. But I think the teams are hard at it. So I'm pretty sure it will be out there in a couple of months. So that will just enable us to do data processing and training both within the Ray framework much easily.
I see. So I think you mentioned some better integration with kind of the earlier stage of the ML process, namely the feature engineering data processing would be
yes.
helpful. Great. Shu, anything you want to add about your experience with Ray so far?
Yeah, so so far we are seeing strong potential, and we actually been collaborating with Anyscale as well as on our side putting Ray into production. The direction we decided is like we do want to incorporate Ray into Uber's production ML stack, and so far we have seen very good results. Specifically, we have been working with Anyscale folks on bringing XGBoost and running on Ray as well as running on GPUs, and we have been able to use that in production at Uber, and this has helped us realize a significant performance gain compared to our Spark-based system. So that's very encouraging. Separately, we are also working on using Ray for deep learning infrastructure. So that allows us to consolidate both the classical ML and the deep learning stack.
Sounds great. So anything that you would like to see in Ray, like both the core or the library or other features to help your use case better?
So I think one comparison point I can get is like, for example, compared to Spark, right? So Spark has is definitely much more mature in terms of the years of its being in production. So the way that it can expose the information, example like Spark History Server. And those kind of metrics and information exposure has been a great help in terms of us using Spark at scale. So Ray is also something. Ray provides some basic functionality in that on that regard, but certainly more of these can always help.
Great. Yeah, Azeem, how about in your case?
Yeah, so I'll just say we're just starting with Ray, right? So we are just close to wrapping up our prototypes that we've been building on Ray. So far, the experience has been great, but we're not as far along as what both Xu and Bhavya mentioned. So I think my feedback is probably a bit premature or a bit early because we're just starting with it. But so far, we've actually been able to put one of our largest models, build a prototype and run training on it pretty easily. Like we were able to do that in 2 to 3 weeks. The part that we ran into, and we're working, like everybody said, we're working very closely, Zhe, with your team, with Anyscale and Ray folks. And it's actually been one of the highlights of all of this is that the fact that we have access to all the open source folks from Ray, and being able to work very closely with your team has made the journey a lot easier. One of the issues that we have run into is that some of our models currently use data flow with TensorFlow, and it embeds the TF transform. We are not able to bring that onto Ray right now because of the Beam APIs, and Beam currently doesn't have a Ray runner and all of that stuff. So we're working through that. I think the team is looking at Dask and a few other things to be able to get through that. But that's been a hurdle. Not necessarily, I would say, a thing that we need to improve in Ray. Like we might be able to work around it. But I will. We're not there yet, but I will reiterate the call that the Xu you made on metrics, because I think the next step after we have our prototype done is to actually, before we put it into production, is to get all the metrics and everything right. So folks, our machine learning engineers who use it, can build their notification pipelines and everything on top of it.
So sounds great. So in terms of additional features that would help you use case better, I think what I heard is better integration in data processing, and I think Xu mentioned better metric support, all these kind of production-ready features. Anything else? So, for example, any kind of bigger features that you have in mind that would make the benefit even kind of more significant or reduce the friction of adoption? I know in each of your cases, kind of migrating existing cases to Ray could be a time-consuming process.
Yeah, it absolutely will be a time-consuming process in our case, but I'm not seeing a shortcut there. I think our engineers have to work with the ML engineers and get that going. But
okay.
Nice. For us, I think another feature request would be to install custom packages inside the Ray environment, but I think that's also in progress right now, so things should be out pretty soon.
Okay. Yeah, that sounds pretty good. I think, right, this is super insightful. I believe actually many other companies that are either trying Ray or looking at Ray for their ML platforms might have similar experience. And actually, yeah, during the conference, I encourage folks to use the live discussion, and I believe all of us, 4 of us here, will be available to chat with you on Slack, the online platform. Definitely looking forward to that. Yeah, so now I want to kind of echo what we discussed in the beginning, right? So the ML landscape in your organization, right? I think you're kind of during the journey of using Ray to revamp the ML platform or build the next generation ML platform. So after you kind of succeed in that, after you have this next generation ML platform, what do you look forward to in the quote unquote new landscape? Is it more about productivity of your ML engineers to do the things faster than what they're doing now, or it's about new kind of things they can do?
So I can start on that. So yeah, for us, I think it's a little bit of both of them. It's a boost in productivity because, like I said, people can use the same drop-in replacement APIs. And also it's about the capability to do new things because, like Azeem mentioned, at Robinhood also, we are having explosion of data, just like Shopify. So our data needs are growing day by day, and we would surely outstrip like single machine requirements very soon. So uh, it would add the capability to train on like huge amounts of data, and finally it would also enable deep learning, which is something our customers are very excited about. So yeah, both productivity and the ability to do new things.
I see. So you mentioned you do anticipate the deep learning use cases to grow over time.
Yeah. The part that's exciting for me at Shopify, I think, as we launch this, so absolutely want to what Bhavya said completely resonates with me. I think it is both of those, productivity as well as new capabilities that we want to offer to all the ML engineers of Shopify. Deep learning, everybody's excited about. Like Bhavya said, productivity we're looking at after we are done with this and it's in production. We would want to build something that brings together the entire life cycle from building, from data prep to deployment in production to monitoring what's in production, into a single surface, if that's what you want to call it, single UI type surface that the folks can actually, an IDE type surface that folks can go from preparing to model all the way to production and monitoring. The part where I think would be a huge productivity boost for us is moving models into production. That today takes a very long time. And I'm really looking forward to be able to move that timeline down from sometimes today to multiple days, 2 weeks, to hours. Like that's our goal this year when we launch this, is to move that down to hours. So that's where we're going.
It's great, Azeem. This is an interesting point because up to this point, I think we have mostly been discussing, quote unquote, the offline part, using more libraries, using more deep learning. Do you mind chiming or shedding some more light on, currently you're saying it's time consuming to move model to production. What are the most time consuming parts?
Yeah, so once we have built a model to take it to production, most of the teams have to actually talk to the folks who are running the Kubernetes clusters. They have to build a service, which oftentimes translates to writing something in Python or writing something in Ruby, because we are generally a Ruby shop at Shopify. Then figuring out how to integrate the models that they have just built with it, how to serve them. The other big problem that folks run into is how to do pre-processing or post-processing when your online inference is coming in to do the online inference. So we are expecting Ray to solve a bunch of these problems, and we have done prototypes to actually demonstrate that it will. So that's the part that we're really excited about. And because Ray cluster is running on the Kubernetes infra, we should be able to spin up a service for online inference really with a few command line runs, as opposed to going through the process of spinning up a completely new service, deploying it in the Kubernetes infrastructure that exists today, figuring out how to run it, figuring out how to scale it. All of those concerns we're kind of trying to bake into the ML platform today.
Yeah, this is very interesting. This echoes to what Bhavya mentioned in the earlier part of leaving more freedom to the data scientists / ML engineers. Is that right? Is that the term you used? Okay, so Azeem, in your case, you're saying in your current workflow, the ML engineers, they are in charge of getting in touch with the Kubernetes infra team and acquiring the infrastructure and developing the model productionization service.
Yeah. And oftentimes they have to figure out how to do that in Ruby, because most of the applications that run in Kubernetes are Ruby based today. Because the rest of Shopify, the Shopify app and the ecosystem is all built on Ruby.
I see. So the ML platform, like the next generation ML platform you're building, it also has a kind of online component, and with APIs exposed to ML engineers, so they can use Python native APIs to specify the logic in their kind of serving application.
Absolutely. ML engineers / data scientists.
Yeah, this is super interesting. Xu, anything you want to add on the kind of lookout for the new machine learning landscape?
Yeah, so the mission of our machine learning platform is to make machine learning and deep learning easy to use, accessible, scalable, reliable, and efficient. So basically going into 2 buckets, right? So one is the ease of use and how we can improve the productivity from engineering point of view, right? How difficult for them to go from a idea in their head to a model in production serving there, right? So at this point, Uber's machine learning platform is rather mature. We're actually able to scaffold a machine learning model within with a few hours, and then we can push models to production very quickly. So of course, like that will give our engineers, especially ML engineer, data scientists, a lot of time to fine tune their model. Speaking of fine tuning, the machine learning platform also provides a lot of tooling. For example, doing hyperparameter search, network architecture search, as well as other assisted kind of like model development techniques, right? So this basically make really lower the barrier of using ML at Uber. What we found is that a lot of business teams and product teams, they could at first they will be reluctant to use machine learning because of this barrier. Like they may not have the right ML engineers in their team, or they may not have the right. They have a different priority, like they have to juggle between spending the resource on doing ML versus spending the resource doing actual, like doing a product development or like a feature, right? So the platform's mission here at Uber is to make this barrier so small that it is almost free for any teams within Uber to try out machine learning. A lot of times, even like someone can do it within a day and then see some result. That is our goal. The other aspect here is on the scale of scale of machine learning. We all know, like especially when it comes to deep learning, it's really the culmination of development in compute, network, and storage. And we have spent a lot of time and effort to ensure like we are keeping up with the demand and train models and do hyperparameter search at scale, right? So that means we are developing actually in collaboration with other companies, including Anyscale, on how can we read data very fast to train deep learning models. How can we have the necessary fault tolerance and elasticity so we can make great use of our GPU clusters, right? So those are like the ongoing work. Looking further, we have been talking about like general, I would say kind of simple stateless machine learning models. So like typically an XGBoost model is a stateless model, and typical like ImageNet or BERT, these kinds of deep learning model, these are stateless. But we also are seeing in the industry a new class of stateful serving or online learning. That kind of model is coming into production and delivering great results. So that is where the Ray can be a great infrastructure to build this kind of application on, because so far I don't see any other technology that enables easily very easy like stateful serving aside from Ray.
I see. So by stateful serving, I assume it's similar to online learning.
It is. I think like online learning has a very specific concept of like you train a model while you are doing that. But in stateful serving, a lot of like you think about an ML application, it has a model and it has some business logic, right? So a lot of times people are already doing some sort of stateful serving, like they build their own system, they have database, or they have sort of like a memory heap behind it, so they keep the state somehow, right? But these are usually done using different infrastructures and different technical stacks. And Ray is I personally see Ray as one potential way of unifying this kind of like separate stacks to do stateful servings into one single application.
I see. That's really exciting. From, for example, Uber's business use case perspective, is it possible to summarize one or two key benefits of stateful model compared with stateless? Is it about the accuracy of the model?
We don't have I cannot share the exact use case of stateful serving at this moment.
But in theoretical point of view, yeah.
Well, the purpose of doing this is to have very fresh features and have the model react faster than what a kind of stateless serving where you train data using using historical and offline data. You train your model using historical data.
Yeah, this is indeed a very exciting potential development. Great. Yeah, we're at the end of this very interesting panel. I think at the end, may I ask each of our panelists to share some advice for other companies who might also want to try Ray? Where should they start? And yeah, to kind of maximize the chance of a successful experience.
I would say two things. Sorry.
No, go ahead.
I'll say two things. One is, get your hands dirty, get it up and running as soon as possible, and try it out. The second thing I think, which is the more important thing, is engage with the team, the Ray team. I think that's been a true differentiator in our case.
Great to know.
Sweet. And I would like, sorry, go ahead, Zhe.
Oh, Bhavya, go ahead.
Yeah, I would also like to just add to Azeem's point. Just to also read the Ray architecture papers. They're very interesting, highly recommended. So you'll get to learn a lot about just ML in general.
Great. Xu, anything to add?
Yeah, I would say depend on the stage of your current your current solution, right? So if you are building a machine learning platform from scratch, I would seriously consider Ray as a potential heavy lifting piece on the technical stack, and maybe just start from now and engage with the Ray team and learn more about how other people are using Ray. If you already have an existing infrastructure like Uber did, what we do was we start to replace part of our infrastructure from their existing solution into Ray. Like this, in our case, we replace the model training aspect of that, and from both Spark and our internal deep learning kind of infrastructure onto a Ray-based solution. Right. From there, you will learn a lot about how Ray works and how Ray integrates with your organization's architecture. And then from there, you can also go see what else you can bring to Ray and determine how Ray will be used. Yeah,
that's a great strategy to minimize the risk. Great. Yeah, thank you so much, Azeem, Bhavya, and Xu. It's a lot of fun discussing with you. Yeah, for the audience, if you have any questions, please reach us either on the shared question answer channel or individually. And I know that these three amazing platform teams are also hiring for new engineers. So yeah, please, if you would like to play with Ray and make a big impact in the machine learning for these companies or the industry as a whole, please don't hesitate. Yeah,
absolutely. Thank you so much. Yes, enjoyed the chat very much, and thank you, everyone.
It's great. Yeah, we should have more.
Yes.
Yeah.
Thank you,
everyone.
All right.
Thank you so much.